Hello and welcome to the Tuesday, November 4th, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Jacksonville, Florida. And this episode is brought to you by the SANS.edu Master's Degree Program in Information Security Engineering. This weekend, we did see a large number of exploit attempts for the XWiki SolrSearch vulnerability. This vulnerability was added to the known exploited vulnerability catalog on Friday, so no real surprise that we see some exploits for it, in particular since this vulnerability has gotten quite a bit of coverage over the weekend. There are a couple odd things about these exploit attempts. First of all, what took them so long? The original advisory that was published by XWiki to alert users of this vulnerability actually pretty much had exploit code attached to it. It had a proof of concept exploit that showed you how to take advantage of this vulnerability, and it was pretty straightforward how to do so. The other odd thing here was the user agent being used by the actor who, according to our data, is pretty much responsible for all of the exploits. Well, this was actually an email address. The email address is with atomicmail.io, which is an encrypted and somewhat anonymous email provider. So yes, certainly something that an attacker may use, but not really sure why they're sort of advertising themselves here. And I haven't really seen this email address being used before, so this seems to be unique to this particular exploit, but let me know if you have seen it before. The other thing is that, well, pretty much as expected, the exploit is used to download an additional script from a website and then execute it. But if you go to this website, you actually end up on a wrapper's promotional page. And the name of the exploit script happens to be an opposing wrapper. They're both like in Chicago, so with different gangs. Both are doing time these days, so unlikely they're directly involved with this. But could be, some kind of fan or whatever who came up with this exploit and is just using these names. Really kind of a lot of stuff here with that, and not sure what to make of it. If anybody has any more details, let me know. I reached out to the email address and user agent, but haven't gotten any reply yet so far. Either way, patch your XWikis if you are using them, and at this point, as always, assume compromise. And then we have an interesting and a little bit of tricky vulnerability that affects AMD's Zen 5 processors. And for a change, it's not one of those speculative execution vulnerabilities or anything like this, but instead a weak random number generator. The RDSEED function, which is meant to create good random numbers, Intel has similar functions in their CPUs, does occasionally return 0, even though, well, that would be not the next random number it's supposed to return, and it also indicates that the result is good. There's a flag that is being set whenever it returns a random number that basically tells you if it's a good random number or not. Well, in this case, the signaling shows success, but the random number is just 0, and that happens more often than a 0 should show up just randomly. There is a patch in the works from AMD for this, but they also offered a couple of workarounds. One, probably that's the easiest in my opinion, to deploy is where you just, to the boot options of your Linux kernel, add an option in order to basically turn off that behavior. Also, if you're using the 64-bit version of RDSEED, then you're not affected by this particular bug. And then again, it's just the Zen 5 processors, even though other processors, of course, have that RDSEED command, but they're not affected by it. For a complete list of all the processors that fall into that Zen 5 category, well, refer to AMD's advisory for this. A little bit hard to tell how exploitable this is. Depends on how often that 0 result is coming back. But of course, from a security point of view, random numbers are being used for many like cryptographic keys and such. So certainly important to fix that eventually. It will at least make it a lot easier to brute force cryptographic keys, even though if it may not still be trivial. And well, malicious extensions via Open VSX appear to not be going away. I mentioned yesterday how they're trying to improve the security of their ecosystem somewhat. The latest example here comes from John Tuckner with Secure Annex. And interestingly here that they basically found this extension that's supposed to help with Solidity, which is a language or a configuration language used for smart contracts. And yes, it's supposed to properly mark them up. But of course, it's targeting people who are working with cryptocurrencies in order to steal credentials. And this is something that really sort of I think I noted with all of these malicious extensions that they pretty much exclusively target crypto developers. So if you are in the business of developing software that deal with cryptocurrency, be very, very careful. That's pretty much the exclusive target of these kind of malicious extensions. Yes, doesn't mean that other developers should be careful, because we also have seen a little bit stuff like cloud credentials and such being stolen. But the number one target here is really developers of smart contracts and crypto coin software. Well, and this is it for today. So thanks for listening, and thanks for recommending and liking and whatever you do to make this podcast more popular. And as always, if there is a story I missed, if there's a story I should not have covered, well, please let me know. Thanks, and talk to you again tomorrow. Bye.